Hi, in this video, I'm going to create a solid model in Solidworks and then open that up in Mastercam and create a 2D pocket toolpath on that part. So when students of mine in the manufacturing engineering class that I teach come to class, they've already had, typically already have had an engineering graphics class where they use SolidWorks to create 3D models, assemblies, and also 2D multi-view drawings. So they're very familiar with using SolidWorks to draw, and so what we try to do in the classes, especially in the manufacturing engineering class that I teach, is to allow them to use SolidWorks to create 3D models for the geometry for things that they will be milling out on the milling machine, the CNC milling machine in the class. And so being able to take that and utilize that solid model in Mastercam is important. This is the first academic year that we're actually utilizing Mastercam 2021. And I in the past, what we had was Mastercam 2017 and had that particular version since about 2017. So or 2017 or 2018. And so what I noted this year when I started working with the SolidWorks files in Mastercam, there's definitely a significant improvement that I can see in terms of how the SolidWorks models can be opened and also chained in Mastercam. So in the past, what we've had to do oftentimes is to create an IGES file and bring that IGES file in and utilize that in Mastercam in order to work with solid models. But now with what appears to be enhancements, and I'm not sure exactly what version of Mastercam those enhancements started with, but again, we're using Mastercam 2021. So not only my students, my current students can benefit from this, but we also have EMET senior design and fabrication semester students who are working on their final projects, and they may also benefit from this because they've already had these classes in the EMET program. And so, but they could have been a couple of years ago easily. And so a refresher on this, but also being able to utilize the new version will be very helpful. So what I'm going to do is a very simple part with a 2D pocket. We'll stick to that, the 4" by 2" by 1" plastic blocks that we utilize in the class anyway, create the solid model in SolidWorks, and then go ahead, bring it into or open it up in Mastercam and see how we can use the 3D chaining in Mastercam to create the 2D toolpaths. So I will start a new part in SolidWorks, and it's going to be an extrusion. So I will just extrude that, the base block, and then create the pocket utilizing an extruded cut. So I will use the extruded boss base function. I'm actually going to create this on the front plane. So the geometry that will end up being on the top plane in Mastercam in order to be machined, I'm actually going to create that on the front plane in SolidWorks. And the reason for that is that if you notice down here at the bottom left-hand corner of the screen, you'll see that the Z-axis in SolidWorks is actually perpendicular to the front plane, whereas in Mastercam, the Z-axis is perpendicular to the top plane. So what I'll do here is, and you'll see this whenever I open it up in Mastercam as well, and perhaps I'll do another video where I'll show you how to change that in Mastercam if for some reason you did not create that on the front plane. But at any rate, let me go ahead and select the front plane here, and I'm just going to use because I'm doing a centered pocket, I'll go ahead and just use the center rectangle function and just left click drag and enter in my 2" height and my 4" width. And I'm going to go ahead and select OK. And I'll just exit the sketch. So in order to actually do the extrusion, I exit the sketch. Another little tip that I typically give people working from SolidWorks to Mastercam, and it's just one less thing that you have to do, and it helps you kind of visualize things when you bring it over into Mastercam, and that's to extrude into the plane rather than out of the plane. So that whenever you open this in Mastercam, we're going to see the grid that we utilize there that has our origin on it, that helps us to draw, and also that we end up using to help us set up our stock, will then be on the top of the part. It won't be on the bottom of the part. So I'm going to set this to 1 inch, so just 1, and hit enter, and then select OK. And so now, I've got my base extrusion. So this again represents that block that I use to machine in the manufacturing engineering class. The next thing I'm going to do is an actual extruded cut to make the pocket. So I will make this, the full-blown 3D model of what this might look like, a part with a pocket that I'll bring over into Mastercam and create the toolpath for them. So in this case, I'm going to use this extruded cut command, and I'm going to select this front face here. And I like to make this parallel with the screen. So I will go normal to here, and I'll just use the center rectangle once again. So if I use the center rectangle again, in this case, I'm just going to make myself a 1 inch high by 3 inch wide rectangle that will create my pocket. And I'll go ahead and select OK. And then I'm going to exit the sketch. And I'm going to make I'll just kind of rotate this around here. I'm going to make this to a depth of 0.6 and select OK. And so you can see I have my pocketed part here. So I'm going to save this to my computer. And I'm actually just going to call this pocket. And I'm saving it as the default .sldprt, so the actual SolidWorks part file. So I'm going to save it. And then I'm going to go over to Mastercam. So I already have Mastercam opened up, and I'm just going to go ahead and open that file. So I'm going to go in, look for my class prep here, and go in and open the pocket. So I do want to note that there is an options here in this, and if you open this up, you'll see different options that you can enable. But what I found is I really don't need to enable any of these. So if I start enabling the edge curves and importing the sketches and things like that, I didn't actually end up with the things that I expected to end up with, I guess is the best way to put it. It seemed to me that it worked much better just opening up the solid part without bringing all these different things in. So as you bring edge curves in, what you're going to see is it's going to behave or look more like a wireframe geometry, which, when we started in the class, I started doing these videos. Obviously, what we were doing was using wireframe geometry in Mastercam. But as it turns out, because at least from what I've seen, because the solid chaining tends to be, or it looks so much better than it did in the previous version of Mastercam that we're using, I'm just going to simply open this up, and it's going to open up as the solid model look that I created in SolidWorks. And I can, the other thing that it does here is, if I go in my toolpaths manager here at the very bottom, there's actually a solids, and it does come in as a solid, which is really nice, because then we can manipulate it as a solid in Mastercam. But again, so what I want to do is I'm just going to go back to my toolpaths, and I want to take this and actually make the 2D toolpath. So use a 3D model, but make a 2D toolpath to machine out this pocket. And the reason that I want to do that is because I want to show how you can use the solid chaining methods in Mastercam to accomplish that. So let me go ahead and I do want to take this and move my origin down here to this corner of the block, just like I did when I did the 2D wireframe in Mastercam. So I'm going to go to transform and move to origin, and then I will go ahead and select this corner right here. And again, to clear those colors, you can just go ahead and go to the Home tab, hit Clear Colors, and then we get back to our original geometry color. So the other thing I'm going to do is I'm going to go to the view and go to top for right now. And I will go to my machine, select our generic Haas 3x mill, and set up my properties. So I'll set up my tool settings and also set up my stock setup. So in this case, what I can do here is I'll hit the display. I'll change this over to here so that this now our corner matches up. So our stock corner or our origin corner matches up with what we have on our graphics screen. And I'll use this All Entities button, and it will select all of the entities here. And so I get my dimensions, my 2-inch by 4-inch by 1-inch thick block. So let me go ahead and just select OK to this. And I will go ahead and put in my one and only toolpath. So I'm going to use a pocket. And in this case, what happens is the solid chaining dialog box comes up, and this is the main enhancement that I have noticed over Mastercam 2017, which has been really nice to use. What I'm going to use is this loop. So in previous versions, it's been actually difficult to even open up a solid part. Which is why we had often gone to the IGES files, and then when we bring those in, typically using the edge curves so that we have more of a wireframe geometry that we can select. But in this case, I can still use this. I can actually select, and I'll kind of rotate this a little bit here. Actually, I want to just go to the isometric view so we can see this a little bit better. I'm actually going to use this loop selection method. And it will be as if, I can still select this outside or top edge of this. And it'll be almost like selecting the wireframe geometry. So it is much easier to select things in this solid chaining than I recall it being in previous versions of Mastercam that we had on campus. So at any rate, this is what I'm going to use as my chain. I'm going to select OK. And again, before I get out of here, again, it automatically, because this is a solid part, it automatically comes up with this solid chaining dialog box. It's in the 3D mode, and it's also in this solids mode for chaining rather than this wireframe mode. And again, the main reason is because it is a solid part, and it's coming in well into Mastercam. Again, I think because of the enhancements or the improvements that have been made to the software package. So let me go ahead and select OK to this. And then it's just a matter of stepping through my 2D toolpath, 2D pocket toolpath here. So I will use a 1/2-inch flat end mill. So let me just as I have in previous pockets here, and I'll select that from my tool library. This happens to be tool number 6 on the machine in the engineering labs. And I'll use, since this is plastic, I'm going to use 20 inches per minute and 2,500 RPM as my feed rate and spindle speed, respectively. I'll use a plunge rate of 20 inches per minute and also a rapid retract, and just put a comment here to pocket, actually, why don't we do cut pocket. So in our cut parameters, I'm going to take down this stock to leave on walls and stock to leave on floors down to 0, because I don't need to leave anything behind in this case for this sample part. In my roughing, I'm actually going to choose the zigzag cutting method. Entry motion, I'll leave as helix. Finishing, I will do just finish the outer boundary. And I'm going to do keep tool down, and machine finish passes only at the final depth. My lead in, lead out, I'm going to go ahead and disable. And for my depth cuts here, I'm going to actually select 0.3 as my depth cuts. And then down here in the linking parameters, I'm going to enable the clearance, use clearance only at the start and end of the operation, and then enable all of the absolute radio buttons, just as I did when I did the 2D toolpath with the wireframe geometry in Mastercam. So again, nothing with the toolpath has really changed, other than now that I'm executing the toolpath on a solid part that I have opened up, that I created in SolidWorks and then opened up in Mastercam 2021. So one thing that you can do here, because this is a solid part, this is actually pretty nice. This is not something you can do with the wireframe geometry because it's not a solid model, but I can click on this depth button here, and then I can actually go over to my graphics screen and select a point that's at the bottom of this pocket, and then it will come up as the depth that I want to actually mill to. So in this case, this is a 0.6 inch deep pocket, and that's exactly how it comes up. It even has the negative sign in there, because once, just like in the other 2D toolpaths that we've done, the top of stock is right here, and so anything that's below that has to be given as a negative number. So I'll go ahead and select OK. And then when I do that, you can see that my toolpath shows up out here. And when I run the simulation, you'll see that it also cuts the pocket. And so, again, very simple part. Just like the other toolpaths that we've done with the pocket, you'll notice that we do, despite the fact that we have sharp corners drawn out here, well, in SolidWorks, but also in Mastercam, when we bring it in, we're always at the mercy of the radius of the tool, which is why we're seeing these radiuses in here. So very rare, again, that you would have those sharp corners, and you would have to determine as a result of your engineering design, your mechanical design, just how sharp of a corner you actually need, or how rounded of a corner you need. But this is, again, to show how to bring in a part that's created in SolidWorks, open it up in Mastercam, and then to be able to execute a simple toolpath on it using that solid chaining. So again, we don't need to use the IGES file in this case. It works very well without that, just using the SolidWorks solid part. So anyway, thank you for watching, and hope this is helpful to anyone out there who is looking to bring a SolidWorks model into Mastercam and utilize it to create those toolpaths. Thank you.